Hey guys, so for today we are looking at part 1 of section 8.2. So I'm starting out on page 223, so turn in your notes to that page so you can fill some of this stuff in with me. Starts out with a little bit of vocab today. So in part 1 we're going to be looking at the arithmetic sequence and common difference, and then in the next lesson for part 2 we're going to do the arithmetic series. Okay, so we're just going to start with arithmetic sequences today. So a sequence is arithmetic if you are always adding something to get the next term in the sequence. So the key word that we're kind of throwing into this is addition or adding. So this is any time I am adding something to get the next term. So for example, let's throw in a simple one here. We'll say 2, 5, 8, 11, ... So if that was my sequence, you guys can see that I am always adding 3 every time to get the next term in the sequence. So anytime you're always adding the same number, that's what makes it arithmetic. The number that you are adding is called your common difference. So for this example, and we always use the letter D for common difference. So in this case, we would have said our common difference is 3 because that's what's being added every time to get the next term in the sequence. Okay, and so that's just what defines this. Common difference is whatever you're adding to get the next term. So if you look at our formula for today, we're going to be looking at this. And so this is the formula that represents any arithmetic sequence, right? This is the rule that we come up with. Sometimes they call it the rule. Sometimes they call it the nth term. So a few different ways they can kind of define this. But this is the rule for arithmetic sequences. A of 1, just as you guys saw in the last lesson, always refers to the first term of the sequence. We just talked about D. D is the common difference. And N is the term number. So first term, second term, third term. Super important thing that I would really stress today is the relationship between A of N and N. And this will come up all chapter long, so pay close attention to this part. The relationship between A of N and N is that N represents a term number. A of N is the value of that term. So for example, let me just go back up to the one we did up here. Let's just say I wanted to identify him, right? The 8. That 8 is our third term in the sequence, right? So that's like saying when N is 3, A of N, the value is 8. So that's how these guys always go together. Okay, so this always represents the term number, and then this guy always represents the value of that term. So let me jump over to some of our examples today. And I'm going to try to work through these fairly quickly. This will be a little bit of a longer lesson, so I'll go kind of quick, so because of you guys can always pause it if you need to slow down and write stuff. Okay, so as I look at this one, they first just want me to determine whether or not it's arithmetic. Well, it's arithmetic if there is a common difference, right? So as I look at these have a difference of 3. Those have a difference of 3. But those have a difference of 5, right? And so this one would not be arithmetic because this one is adding 3, and then I'm adding 5. That's not a common difference, right? You always have to be adding the same number every time to get the next term. So that one is not arithmetic because there is no common difference. But look at this one. This one is going down 3, down 3, down 3, down 3. So you guys can see that this one, so technically if it's going down, I know we always think in terms of addition for this, like a common difference, but it can be negative, right? So in this case, there is a common difference between these. It's simply -3, right? Because it's going down 3 every time. So we would say yes because the common difference is -3. Take a look at number 3 with me. I show you this one only to tell you there's a little bit of a help when you're ever trying to figure out your common difference, right? Because some of these are going to be kind of tough to figure out. It could be decimals, it could be fractions, whatever. If you're ever unsure of your common difference, here's one way you can always find it. You can take any term and just subtract the previous term. So what if I took my second term and I subtracted the first term? And you guys could probably tell what the common difference is here anyway, but just in case you run into one that's harder and you're having a hard time figuring out what the common difference is, take any term and subtract the previous term. So in this case, if I took my second term and subtracted the first term, I get 0.2. And so that's an easy way of identifying my common difference. So you can take any term, subtract the previous term, and you can see that one's consistent all the way through. They're adding 0.2, 0.2, 0.2, 0.2, right? So that would be our common difference. All right, jump down to number 5. So this is the one where we're using the new formula today to write a rule. And let me just write it because it was on the previous page. So the rule said this: A of n is equal to the first term plus the term number minus 1 times the common difference. So that's what our rule looks like today. So remember in the first lesson, you guys had to figure out a rule by just saying, what am I doing to 1 to get 3? What am I doing 2 to get 9? 3 to get 15? And that's a hard way to look at it. If it's arithmetic, then we can use this formula to get the rule. So let's just plug some stuff in here. So we know that our first term is 3. We're leaving n as n. So, guys, when you write a rule, we leave n as n because we want this to represent any term number in the entire sequence. So a general rule is supposed to be applicable to any term in the sequence. So we just leave n as n. We're not putting a specific term number in there yet. The common difference. So you can see they are adding 6 every time to get the next term. So our common difference is 6. And let's just clean that up a little bit. That's really the rule. That's the rule, but we're just going to simplify it. So I'm going to distribute the 6. So it would become 6n minus 6. And then I'm going to combine those like terms right there. So I'm going to put the 6n in front, and 3 and negative 6 would give me minus 3. So that's our rule. And it's good to simplify, so I would encourage you guys to go that far with it and simplify it. So that is now the rule of that sequence. And now we can use that rule to get things like this. So when they say find the 20th term, well, all I have to do is plug in a 20 for n. And that will give me my 20th term. The appropriate way to write it would say we're going to find the 20th term by simply plugging in a 20 for n. So that's what our setup is going to look like, and we'll just do a little cleanup on that. You can do this in a calculator. So 6 times 20 would be 120 minus 3 would be 117. So the 20th term in that sequence, so if I kept going on this and kept adding 6, adding 6, adding 6, all the way to the 20th term, that's what we would find. Okay, so we had the rule, we have the 20th term, and let's jump down to this one. So we're going to do the same thing on this. Guys, you can always, like, this is probably what I would have you do in class, is I would have you at this point, like, stop and try one on your own. So if you want, wouldn't be a bad idea to kind of pause right here and try this on your own. I'm going to start with this, and I'm going to use that formula to write the rule. So we're going to say A of n is equal to our first term plus n minus 1 times our common difference. So what is our common difference? Looks like on this one it is going down 0.5. So minus 0.5, minus 0.5. So when it's decreasing, we got to see that as a negative 0.5. So again, that's really the general rule, but I do want you guys to simplify it so it looks something like this. So we're going to distribute the negative 0.5. And then I usually put the term with n in it first. So I'm going to start with negative 0.5 n. And then I put my constants at the end. So if I did 0.7 plus 0.5, I get 1.2. And that would be our rule. And again, now we can use the rule to find the 20th term. So we're going to say a sub 20 is equal to, and all we're going to do is take the rule, and we're going to plug in 20 for n. So it looks like this. And then the rest we'll do in calculator. Throw it in real quick. So negative 0.5 times 20 plus 1.2. So the 20th term of this sequence would be negative 8.8. All right, let's jump over to our final two problems. So I'm going to give you two more. We're going to do 9 and 10 on this page. On this one, we're still writing the rule, but they're telling me the information in a bit of a different way. They're actually telling me that the 12th term is negative 13, and the common difference is negative 2. If you notice, the one thing I don't know is the first term of the sequence. When we write a rule, the two things that you need to know are the first term and the common difference. So for this one, we already know the common difference. We're going to have to figure out the first term of the sequence. So I'm just going to rewrite the formula so it's in front of us. So it looks like this. And just so I know before I forget, we're not going to graph these, so you're not graphing. So if you run into any today in your assignment that asks you to graph, you don't have to do the graphing part. Just do the part that I'm showing you right now. So let's just plug in what we know. Guys, this is that super, super important concept that I was pointing at earlier. Remember, what this tells me is my 12th term, in other words, when n is 12, the value is negative 13. That's these guys, right? So that's like saying when n is 12, the value is negative 13. And so we're going to plug those into our formula so that we can figure out what this first term is. So there's our setup, and we're simply going to solve for the first term of the sequence. Let's do a little cleanup right here. 12 minus 1 is 11, and 11 times negative 2 would be negative 22. And then we're just going to add 22 to both sides. Let's see, negative 13 plus 22 is 9. All right, so we found our important piece of information. We know our first term. We know our common difference. Now we can write the rule. So you're always going to need to know those two things before you can write a rule. So I'm going to go back to my formula, and we're going to write a rule just like we did on the previous problem. And then when you write the rule, all we plug in for is the first term, which we now know is 9. And the common difference, which we know is negative 2. Remember, when you write the rule, we leave n as n, because we want this rule to fit any term in the sequence. So let's do a little cleanup. We will distribute that negative 2 and I like to put the n in front, so negative 2n. Not that it really matters. 9 plus 2 is 11. So if you were to switch the order on those and you wrote this as 11 minus 2n, totally fine. Right? You can do it that way. All right. By now you're ready for the challenge problem. So this is our last one, but this is our toughest problem. So stay with me on this. We are going back to a concept of solving a system of equations. So you guys have solved a system of equations. That was a first semester thing. So I'm going to kind of remind you of that process as we go through. Here's the issue. Remember, to write a rule, we need to know a first term and a common difference. We don't know either of those things on this one. We don't know the first term or the common difference. So whenever you have two unknowns, well, then you need two equations. So I'm going to go back to my formula, and let me just rewrite it. I always like to have it in front of me. Ignore this one. We're not doing this one. So there's our formula, and let's just plug in this information to get our first equation. This is telling me that the 8th term is 59. In other words, when n is 8, I have a value of 59. So I'm going to plug those in. Don't know my first term. Our term number for this one was 8. And we don't know our common difference. So that's our first equation, and we'll simplify that to a 7 here in a minute. Let's do the same thing for this one. This one says the 13th term is 99. In other words, when n is 13, my value is 99. So let's sub those in. First term number is now 13. Don't know the common difference. Okay, so we have our two equations, and now we're going to solve a system of equations. Let me rewrite those and simplify these first. Be a little easier to look at. Okay. So here's our system of equations. Guys, you've learned 3 methods for solving a system of equations: elimination, substitution, and graphing. We're never going to do this by graphing, so your options are really elimination and substitution. When you're doing arithmetics, these are perfectly set up for elimination. Elimination was the one where I should either be able to add or subtract everything, and something should get eliminated. And in this case, if you look at these, well, if I subtract this minus this, it would get eliminated, right? They would cancel out. So what we're going to do here is we're going to take our top equation minus the bottom equation so that my A1s will cancel. So I'm going to do 59 minus 99, which would be negative 40. A1 minus A1 is nothing. Those guys cancel. That's why we call it the elimination process. 7D minus 12D would be negative 5D. Now we have a really easy equation to solve. I'm just going to divide both sides by negative 5 to figure out the common difference. So we now know our common difference is 8. So how do we get the first term? If you remember from solving these systems earlier in the year, once you know one of the answers, you can always plug it back in to get the other guy. Okay, so I'm just going to pick the easiest equation that I have. It doesn't matter which one you pick. I'm just going to go with the easiest one, which I think is him. So I'm going to take my 8 and plug it in for D so that I can figure out what this is. And I'll just do that over here to the side. So I got the 59 equals A1 plus 7 times D. And we now know D is 8. So we're going to do that. And let's just solve that equation. Would look like this. Subtract 56 from both sides. And now we have our first term. We now have the two things that we need to write a rule: a first term and a common difference. So let's go back to our formula, and we'll end on this. But again, now I'm going to rewrite the rule now that I know what these two guys are. So the rule, is our first term, which is 3, plus n minus 1 times the common difference, which is 8. And that's our rule. So we'll simplify it like we always do, but essentially that's the rule. So distribute the 8, and then just combine like terms. And that's our rule. And so this is what we were shooting for. All right, that's it for part 1. Part 2, we'll deal with some series of arithmetics, but that is it for today.